Okay, everyone. For our online lessons and only our online lessons, I'm going to go ahead and record videos in case you want to look back. Again, this is not really what you guys signed up for. So let's talk about the lesson we did Tuesday, which is on functions. And excuse me, we started out with some basic definitions. What is a function, or what is a relation? A relation is a relationship between two sets that contain one element from each set. The set of inputs is the domain, the set of outputs is the range. And if we're looking at graphing, of course, we're looking at X and Y. So if we look at this relation here, which is called a mapping, we see that we have a bunch of names and their ages. So what's in the left here is our input, and the age is the output. Now, these are listed in alphabetical order. These are listed in numeric order. And how do you tell what goes with what? It's the arrow. They don't necessarily line up. First of all, they're not the same number in each of them. Okay, but we can match up information in here. So, for example, if we want to know what is Debbie's age, well, we look at Debbie and we follow the arrow to where the age is, so we find that Debbie is 67. If we want to know who is 45 years old, we can start with the output of 45, and we see that Rick is the person who is 45 years old. If I want to find the domain of the relation, it is the set of all the input values. Now, it is a set, so if we're going to do a set, we put it in set brackets. So if I want to find the domain, then I just list all of these, and I put them in a set. So that is Amy, Debbie, Rick, Sarah, and Will. So this is the domain. And then this is going to be our range. So if I want to find the range, again, I open my set brackets and I just list the elements. 36, 45, 67, and 70. Now, listing them as just domain and range, then we don't know what goes with what. But we can write the relation as a set of ordered pairs, and the ordered pairs are going to be an input and its corresponding output. So if I wanted to write this set, and I didn't leave myself quite enough room here, I'm going to have to write small. I know that Amy, her age is 45. I know for Debbie, her age is 67. I know for Rick, his age is 45. I know for Sarah, her age is 67. And finally for Will, he's the old man of the group, he's 70. Okay. Well, now there is a special kind of relation called a function. And it is, so we want to make note of this definition because we're going to deal mostly with functions in here. It is a relation in which each input has exactly one output. Okay. So when I'm asking for the relation above, if it's a function, what this is really asking is, does every name have exactly one age? And the answer is yes. And it's because every name has exactly one age. But when you're trying to see if something is a function, that's what you're going to ask. Does every element in the input match up to exactly one element in the output? Okay, so let's look at this relation here. And we want to know, is it a function? Now, some of us can tell from here, but others of us may want to look at the relation. So we're going to look at the mapping, and we are going to list our input values and our output values in numeric order. So my smallest input value is 0, then I have a 3, and then I have a 4. So I have a 0, a 3, and a 4. The 3 is repeated, so I don't have to list it again. My output values, the smallest of the y coordinates is -2, then 0, then 1, and finally 5. And now I just have to match them up. So an input of 0 matches with an output of 0. An input of 3 has an output of 1. An input of 4 has an output of 5. And an input of 3 has an output of -2. Okay. So from either looking at this or looking at the mapping, can we determine if this is a function? Okay. Well, the answer is no, it is not a function. So the answer is no. Why? Because an input of 3 has 2 possible outputs. So we can write that as our answer here. The input 3 has 2 outputs, -2 and 5. So that is what prevents it from being a function. Okay. So if I look at the mappings on, well, first let's go ahead and find the domain and range. We've already taken care of that here. The domain is 0, 3, and 4. The range is -2, 0, 1, and 5. Now, what difference do you notice between the two relations? Well, there are a couple of things. So for the names, and we're looking at a map, each name has a single arrow. Matching with an output. And then for the ordered pairs, the input 3 has 2 arrows. This means it's not a function. Now you can also think about it in terms of the ordered pairs. In the ordered pairs, here every input of the ordered pair is not repeated. Here you have a repeated input value of 3 that goes to 2 different items, 3 to 1 and 3 to -2. Okay, so that's the basis of a function, and we'll do more of it in our next lesson. We'll look a little bit more at graphs. All right, so let's look at what we call function notation. Function notation is this. For an element, for x, an element of the domain, f of x, which is pronounced f of x, is the corresponding element of the range. This means that a function of the input is the output, or more commonly, f of x is equal to y. Because you normally, in your ordered pairs, you're going to look at an x or a y, which is the same thing as the input output, or x f of x. Okay. Okay, so if we're given this function, and let's just verify it's a function, each one of the inputs is different, so we know it's a function. We want to find f of 3. What this question is really asking if x is 3, what is y? So you're going to look at the point 3, 4, and if x is 3, then f of x is going to be 4. Okay, so don't get bogged down in the notation. It just means if x is something, what is the y that goes along with it? Okay, so if I want to evaluate a function, I can do that. And what it means, if you're given a function f of x, to find f of a, you just replace x with whatever you want to find, and then you simplify it. Okay, so let's say I start with f of x equals 2x minus 3. That's my function. And I want to find f of 0. Okay. Well, the 0 is my input. So now I need to find the output. And to do that, I just replace in the function x with 0. So this becomes 2 times 0 minus 3, which is negative 3. And that becomes my output. So if I write that as an ordered pair, my input, my x is 0, my output, my f of x, is negative 3. Okay. Well, let's say I want to look at f of x, same function, f of x equals 2x minus 3, and let's find f of negative 2. Of course, negative 2 is my input, so I'm just going to replace x in my function, so that's 2 times negative 2 minus 3, which gives me negative 7, and of course that becomes my output. So my ordered pair is my x and my f of x. Okay, so if I have the function f of x equals negative 5x plus 1, if I want to find f of 5 minus f of 3, then I'm going to start by finding f of 5, which is negative 5 times 5 plus 1. Negative 25 plus 1 is negative 24. And then I'll find f of negative 3, or excuse me, f of positive 3, I'm sorry. So f of 3 is negative 5 times 3 plus 1, which is negative 14. So then f of 5 minus f of 3 is equal to negative 24 minus negative 14, which is the same thing as negative 24 plus 14, which is negative 10. Now you might want to put a little star by this one, because this, if you can replace the variable with an expression. And all that means is at the end, you're going to have an expression. You're not going to come up with negative 10 or 3 or 7. You're going to have a variable in the expression. So if I find f of x plus 3, then that's going to be negative 5, and I'm going to replace x with x plus 3, plus 1. We're still dealing with the same function. Okay. Now I still need to simplify it, so I can distribute. That gives me negative 5x minus 15 plus 1, which gives me negative 5x plus, minus 14. So f of x plus 3 is equal to an expression. Okay, now why are we focusing on these skills? We're focusing on these skills because we're going to be dealing with functions that model so many things in business: revenues, cost, production, whatever it is. And this particular example talks about the global revenue in billions during year X for the Estée Lauder companies. They can be approximated by this function, R of X. It doesn't have to be XF here. It can be any variable, R of X. Usually we use R for revenue in business. And this only applies from 2016 to 2021. We're going to deal with different things for different time periods. So we want to evaluate R of 20 and then interpret the results. Okay, so the first thing we want to do is evaluate R of 20. We know now that that means I'm going to replace X with 2020. So R of 2020 is equal to 0.742 times 2020, excuse me, minus 1484. And if I just plug that into my calculator, I get 14.84. But now we have to interpret the result. What does this mean? This means that in the year 2020, remember R of X is the global revenue in billions of dollars during year X. Global revenue was 14.84 billion. So we need to be able to find that result as well as figure out what it means. Okay, so let's look at our last function here. For the function g of x equals x plus 1 over x plus 3, if I want to find g of 0, well, that means I'm going to put it in here. That's going to give me 0 plus 1 divided by 0 plus 3, and that's going to give me 1/3. Now notice I'm asking this question a little bit differently. The point on the graph is the ordered pair x f of x, or xy. So if my input is 0, my output is 1/3. Okay. All right, well, let's try g of negative 3. Same thing, I replace the x in both places with a negative 3. So that gives me negative 3 plus 1 divided by negative 3 plus 3, which gives me negative 2 over 0. Okay, so let's make a note of this one. Division by 0 is undefined. Now my tip on that is try dividing a pizza into 0 pieces. You can't do it. Cannot do it. This means that g of negative 3 does not exist. And we'll talk about that more on the next page or when we start the lesson on Thursday. So the point on the graph, there is none. It is undefined. Okay. All right, well, that's it for our first one. We will finish 2.1 and probably get started on 1.2 next time. Thank you.